indexing, and SQL Profiler, a database tuning advisor. These are the three things we have to discuss in the SQL Server part. So, what is an index? Any idea, Murali or Chaitanya? What is an index?
It is, yeah, it is for okay. It is to improve the query performance. Okay, it will physically reorders the data, okay, in a particular order, and okay. So
Right. The simple example is how the index is going to help for us. You have a book or whatever, so you have a lot of chapters, 10 chapters and 200 pages. If you want to find out a particular chapter number, so I want to see the chapter number 9. How can you see the chapter 9 in a particular book? So you have to start from the page 1 onwards until you are going to find out the chapter number 9. So you have to scan the entire book. When if you don't have any index page, the starting of a book, if you have the index page, so what the index page having, what is the chapter name, and what is the content of that particular chapter, and from which page number to what is the end of the page number. It will give the clear description about the starting page number, ending page number of a particular topic and a particular chapter. So once you are looking on the index page, what is the page number of a chapter 9? So once you are finding the page number, then directly you can go to the particular page number instead of searching from the starting page onwards. Okay. The same way, even in SQL Server as well, whatever the data you have in a particular table, okay, whatever the data you have in a particular table, if you want to find out a particular employee information, this employee information, how the SQL Server is going to find out this employee information? Definitely, if you don't have index concept on this particular table, what it will do? It will try to find out and it will scan the entire table from starting onwards. So how much time it will take to scan the entire table? If it is a small table, then you no need to worry. If we have 1 crore records, 1 million records, 1 billion records, so in that situation, how much time it will take to find out a particular record? Definitely it will take too much time if you don't have the indexes. In the performance point of view, the best and first thing you have to remember and you have to focus is index only. If someone is asking your manager or in your team a particular query or a particular database is taking too much time to give the response in a particular application for your query, so the primary thing you have to focus on the indexes only, whether these tables having the proper indexes or not, and inside that query whatever the tables you are using, those tables having indexes or not. Okay, so if you have the index on this particular table, then easily it will directly go and find out a particular employee information over here. So when you are creating any indexes, what will happen in this particular table? We have two kind of indexes. One is a clustered index, another one is non-clustered index. How many clustered indexes you can create on a single table?
One, only one.
Only one clustered index you can. So if you want to create a clustered index on a particular column, what is the eligibility criteria for that particular column?
Key column. It should be a key column.
What key column? Foreign key, unique key, primary key?
Primary key.
Right. So that should be a primary key column in the SQL Server. What do you mean by primary key?
Uh,
If a column is a primary key, then the data existing inside that column is no duplicate
and, and not null also.
and it don't
Not null.
even single null value. So if you want to create a clustered index on a particular column, that column should be no duplicates and no null values. Chaitanya, please put in mute. Whenever you want to ask any question, you just unmute it. Some disturbance is coming. Okay, right. So one suggestion over here is whenever you want to create any indexes, try to choose numeric data types. Numeric means either numeric or integer, whatever, because the string data types are not suggestible to create the indexes. Those will occupy more space to create the indexes on a string data type varchars and varchars. So I have employee number, employee name, job, manager, hire date, salary, commission department. In this table, what is your suggestion to create a clustered index?
Employee number.
Right, employee number. Okay, because this employee number don't have any duplicate values and don't have any null values. So I can create the clustered index on this employee number column. Okay,
Ram, I have a question.
yeah,
Is that necessary that a clustered index should be only on a primary key, or we can keep it on any other column also,
you can
which
keep
is
it on
like,
any column. You can keep it on any column, but that column should be no duplicates and no null values. Okay, whatever the column you are going to create the clustered index, that column.
see, if employee number, I put it as an primary key,
Okay,
but it is an automatically it creates an unique clustered index, right? So I doesn't want the clustered index on the primary key column. I want to make any other column as an clustered index column. Can that be possible? Like one can be primary key without clustered and another column with a clustered index.
yes, definitely, but definitely that is a bad design of your data model. A single table, if it has two primary key columns, then that is a bad model. If you observe in any dimensional modeling or any fact tables or dimension tables, those should have only one primary key column. It might be a composite primary key column. What is a composite primary key column? Any idea? If
One or more,
yeah,
two or
if
more
one
columns
column,
combining to form an.
yeah, one column is not sufficient to form a cluster or primary key, this column having some duplicates, and when you are combining more than one column, the combination of employee number, employee name, job, then you can make it as a unique key or primary. Okay, so then that is a composite primary key column. You can create the indexes on this combination as well. Okay, but only one clustered index on a particular table. So you can disable when you are creating a primary key column on a particular table, it will create a unique key clustered index automatically. Yes, you can disable that one as well. Where you can disable, for example, in this emp table under the design, we don't use this frequently. So here you can change somewhere. I think we have to disable this one when we are going to create the table. Okay, anyhow, see, automatically it has created the clustered index on the primary key column. I have the primary key column on the employee number, and I have create then automatically it has created a clustered index on this one. Okay, so here somewhere you can okay, if you want to delete this one, yes, you can delete this index, and you can create a, you can delete this index, and if you want to create in another column, you can create the new clustered index on that particular column. Okay, but the problem is, mostly in, if you observe in the dimension modeling, in the dimension tables, there is only one column is eligible to create the primary key or clustered index. That is nothing but surrogate key. Okay, so we'll discuss about this data modeling and data warehousing concepts in once we are entering into the MSPA. What is data warehousing? What is a dimension modeling? What is a fact table? What is a dimension table? How they are going to design these surrogate keys? What is a business key? All those things we'll discuss later. Okay, we just focus right now on this SQL concepts. So I'm going to create the clustered index on the employee number column. Okay, so once you are creating the clustered index on this employee number column, it will sort out the data. It will put the data in a specific order, either it is ascending order or descending order. Okay, so that is the reason we can create only one clustered index on a particular table, because it will sort the data. Again, if you are going to create another index on a particular table, again the sorting will change. Okay, so that is the reason we can create only one clustered index to uniquely identifying the record. That should be a primary key column 99 percentage, and it is better to create the clustered index on a numeric value. Don't choose this kind of employee names or job names, the varchar or string data types. Okay, right. So sometimes if you don't have any idea how to create indexes and what columns we need to create the indexes, then how we can know on what columns we need to create the indexes and on what columns we need to drop the indexes. Sometimes if we have more indexes, then that will impact your performance. So basically the indexes will helpful only for selecting the data, to find out the what data is there inside a particular table. But when you are going to insert the data into that particular table, so what will happen? Then the insert or update statements when you are doing on this particular table, if you have indexes, then that will impact your insert update statements. Those will take too much time. So that is the reason sometimes in SSIS, when we are going to do some insert update statements into a particular table, we will drop the indexes and we will do our operation, whatever insert or update, and then we will again rebuild the indexes. We will recreate the indexes. Okay, so what is the advantage if you are creating if you are rebuilding the indexes, and how to create the indexes? There are two kind of indexes. One is a clustered unique index, and the next one is non-clustered unique indexes. So how to create an index and what is the syntax for the index and what columns we need to create the indexes, you no need to worry. We have one pre-built in the tool, and so that will analyze your data and it will give suggestions to you on what columns and what table and how many indexes, what kind of index you have to create. It will give a clear picture about that one. Then you no need to worry about that indexing part. Right. Recently in SQL Server after 2012, there are new kind of index is coming, that is column store index. Did you hear about this one? What is a column store indexes?
It's actually it is a row. Okay, column store format. That is that there are two type of storage modes are there actually: row store mode and column store mode. So
Yes,
it will have some, yeah.
when you are creating these clustered non-clustered indexes on this SQL Server, earlier it will store the data in the rows wise. Okay, when you have created indexes, then it will take this entire row and keep over here, and the second row it will keep over here. It will store like a row by row, row by row, row by row, row by row. When you are going to fetch for a particular record, what will happen? First, it will keep all the entire row into a memory, and from there it will choose whatever the columns you are selecting. So when you are creating the indexes, what will happen? It will store this entire row data, and when you are going to select that data, I want only employee number, employee name, but it will fetch all the rows from your physical store to memory, and from there whatever the columns you are going to fetch, what columns you have specified, employee number, employee name. But now the situation in the column store index is, what will happen? It will store each column wise employee number, and separately employee name, and separately the next column. And when we are going to assess AS part, analysis services, so in analysis services there is a column store index, and how it is going to store the data. It is a vertipack engine. That engine you can find out in your Excel as well, and in your Power BI also. In the Power BI, how it is going to store the data into in memory, and when it is going to store the data from your data source. If you have 10 GB of data over here, when it is going to store the 10 GB of data into the memory, it will shrink up to 4 GB. It will store the 10 GB data in within 4 GB of memory only. How it is possible? Because of this, the kind of storage is column storage, column index storage. So simply what it will do, for example, when it is going to store the job, what is a job, how many different kind of jobs over here. So it is going to store the jobs like job clerk, salesman, manager, analyst, that's all. But here clerk, salesman, manager, salesman, manager, it is repeating more than, but it don't repeat. Whatever the distinct values are there, it will store only those values. And also it don't store like a numeric string values. It will decode, the values. What are the possible values to store with the better memory? So these string values it will convert into some numeric values, 1, 2, 3, 4, like that, and it will store these values. So instead of storing these many strings, these many characters and bytes of the space, okay, it is better to store these values 1, 2, 3, 4. That we will discuss later in the SSEAS part. So as of now, as a SQL developer, what you have to focus is how to create the indexes. Okay, in a particular table, you can create only one clustered index. You can create a many number of non-clustered indexes. So what is a non-clustered index? What is the difference between clustered index and non-clustered index? So normally the clustered index you can create only one on a particular table, and that should be a primary key column, and it will sort out the data and it will store the entire data into a particular column index. Okay, so the non-clustered indexes, there is no limitation. But in 2005 we have the limitation up to 249 non-clustered index per particular table. In 2008 R2 version we have 999. From 2012 version onwards, we don't have any limitation. You can create as many non-clustered indexes you can create. Okay, so when you are going to create a clustered index, it will store the actual data in the leaf nodes. What do you mean by leaf nodes? For example, when it is going to create any clustered index, or when you are going to search for a particular value 7698. Okay, here I have 14 employees information. I'm going to look for a particular employee information. Select star from the emp table where employee number equal to 7698. Okay, so this index, it will divide the whole total employee numbers into 50-50. For example, I have the employee numbers from 1 to 10. So here in this branch it will select 1 to 5, and here it is selecting from 5 to 10 the employee numbers 1 to 5, 6 to 5. So now you are looking for which employee? I am looking for the employee number 4. So this employee number is in which side the number is? Yes, definitely it is this side. So it will come over here. So in this branch, what are the employees information you have? So here again it is going to divide into 50-50, 1 to 2, and this is 3 to 5, like that. So your employee number 4, in which location the employee number is 4? Here in this part. Okay, so once it is reaching here, here the actual data it is storing whatever the employee information, that is employee number is 4, his name is Ram, and what is the job, manager, and every information is there. So it will fetch and show to you, it will display that result. So how it is going to search the value? Simply it is searching in 3 steps. First it is looking just whether the value whatever you are searching is greater than or less than whatever the value here. Yes, it is less than. Then coming to this part, then again it is coming to under the range of 3 to 5. So immediately it is finding that value. It is not searching or looking in other employee numbers from range 6 to 10, and also it is ignoring the 1 to 2 range as well. If you don't have index, what will happen? It will search from 1 to 10 range. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It don't stop once it is finding the fourth position. For example, I have 1 to 10. It is trying to find out 1, okay, not matched, 2, not matched, 3, not matched, 4, not matched, 4 matched. So it will get the fourth record. And if you don't stop the searching, it will search even it is finding the fourth record until it is reaching the 10th record. The entire table it is going to search. The reason, it don't know whether the value 4 having only one time in this table, because if you don't have the clustered index, it might be more than one employee number in that particular table with the 4. If we have the clustered index, what is that meaning? If you have the clustered index, what is that meaning? Definitely each employee number should have only one time. So once it is finding that employee number 4 one time, you no need to search in another employee numbers. Then you no need to search forward, because only one record we have in the table that already we are finding matching. Then you don't find any record with that, you no need to search for that value. It will save the time for the searching the records. Okay, but in non-clustered index point of view, what will happen? Right, for example, if you are not writing a select start from emp where employee number equal to this number, we are not searching for a value on employee number point of view. Then we are going to write down a particular job number. That is non-clustered index. I have a non-clustered index on the job column. I'm writing a SQL query select star from EMP where job equal to salesman. Then how it is going to start the searching and how it is going to find out the value. So what will happen whenever you are creating the non-clustered indexes? Those non-clustered indexes will save the key values. So this salesman is going to store whatever the non-clustered index key values. So this 7699, this employee, what is the when it is creating a clustered index, each one having creating some key column, key values. So each non-clustered index column, each value is going to store some key values in the leaf nodes. But in the clustered index, what will happen at the end of the leaf nodes? Those having some data, the actual data, those are going to store. So immediately once you are finding that value in the cluster index searching, it will immediately fetching that value. But in non-clustered index, what will happen? Whatever the non-clustered indexes you have created, those non-clustered index at the end will store that key values of the clustered index. So based on that key value indexes, finally it is going to fetch the data from your table. Okay, so if you don't have non-clustered index, I don't have any non-clustered index on a particular table, and I'm writing a query select star from emp where job equal to salesman. The job column don't have any non-clustered index. What will happen? So definitely those don't have any key values and don't have any indexes. Then it will try to find out the searching value for the entire table, and those are not storing any values, those are storing row identity number. It's not a number, it's a combination of something, what is the id of the column, the address, we can say the address of the each column, each row. So it is difficult if you don't have non-clustered indexes. So that is the reason we are going to create clustered index is must and should on a particular table, and those frequently whatever the columns you are going to write down on a where condition. So you can create non-clustered indexes on the frequently using columns. If you are using some columns not frequently, very rare, if you are creating any if you are using in the filter conditions or in select columns, then you don't need to create the clustered non-clustered index on that particular columns. Okay, and also you can create unlimited non-clustered indexes, right? But the problem is if you are creating more non-clustered indexes when you are going to insert the data, then definitely it is a problem. Okay, for example, I have created some indexes on this table. The one disadvantage, one thing you have to remember, if you have more indexes, those will occupy more space. If you are creating indexes, those will need some space to create the indexes on that particular table. And when you are going to delete some records on a particular table, for example, I have created a clustered index or non-clustered index on this table. I have total 1, 2, 3, 4, 5, 6 until 14 rows. You have deleted something 4 records in a table, okay, but the index whatever you have created is built whenever you have the 14 records, okay, but there is a gap is coming after you are deleting the records. Okay, so in that situation what will happen? whenever it is going to search for the value, there is no record for this particular key values whatever you have created. So this is a waste of time. So that is the reason we are going to rebuild the indexes. Not frequently, at least once a week based on your data updation. If you are going to delete some records, then there is a gaps in between the data storage in a particular pages. How the SQL server is going to store the data? Like a pages. It will divide your memory into pages. So each page having how many? No, the table is just for in the front end view, that's all. But in the background, how the SQL server is going to store the data? It will divide your 2 GB or 3 GB or 4 GB of memory into pages. Each page, 8 pages of space we are calling one extent. Each page having 8 KB of data. Okay, so 8 pages. Each page having 8 KB of space. This is called 8. The combination of 8 pages is called one extent. Okay, so when you are going to store any data into a particular table, the table is just front end view, that's all. This is not the actual storage, but internally when you are going to store the data, it is going to store the data like this: extents, pages. I think I'm not sure whether extent is the top one and page, extent, page, and we are calling it's a record or whatever. We'll see here. Right. A extent is 8 physical continuous pages. Right. An extent is, this is one extent. Each extent having 8 pages. Okay. Each page having 8 KB of the space. So when you are going to store the data, first it will select one extent, and inside the extent, first it will find out one page, first page. It will insert the data into first page, and then if it is full, it will go to the second page. Each page having only 8 KB. Then it will go over here. By mistakenly, if this is inserted only half of the space, and then the second time if a new record is coming, it will come over here. So when you are deleting the data, what will happen? For example, employee number something fourth has inserted in this extent in this page for this 8 KB of the space. After you are deleting, so this page is empty. Okay, this page is empty. So then there is some gaps is coming in that particular pages. So once you are rebuilding, and those will, even when it is going to create the indexes also, it will go and store like that. So if you are rebuilding, that spaces will shrink, it will fill that spaces. Until you are not rebuilding that indexes, the space is not filled. Okay, right. So now what I'm going to do here, when you have this application server, from application, this is a red bus, simple example, red bus application, and they have the database in SQL server. These people's application is running very slowly. What is the reason the application is running slowly? As a database developer, there may be a lot of reasons. It's a network issue, or their application is built by Java or .NET, whatever, web methods, whatever. So, but as a SQL developer, you have to find out, is there any SQL response, is there any stored procedures, is there any SQL queries, whatever you are using inside, if those are taking uh, some too much time sometime. So what procedures are running currently over here, and what queries are taking how much time in a particular database. So how can you find out that information? How can you trace out that information? How it is possible? So that is possible. You can go to the tools under the SQL Server Profiler. So this SQL Profiler will trace the current information in your database, in a particular database. For example, I'm going to use this AdventureWorks DW2012, and this particular database you can trace. Okay, for example, I'm going to use this particular database uh, for my redbus application. In this database currently, what are the processes, what are the SQL queries are running, what are the procedures are running, and how much time those queries are taking, I want to trace and keep inside a file. Okay, so the template you can use tuning template. Okay, and what is the trace name? Yes, you can give any trace name, trace 7:30 am, or you can give red bus, whatever. Okay, so just come to event selection. So I don't want to trace all the information in this entire SQL server because I have another databases as well. So that is the reason, go to column filters under the database name, like this AdventureWorks. Only for this particular database, whatever the SQL queries are running, I want to trace only that information. What information you are going to trace? Whenever a stored procedure uh, execution completed, or sometimes we are writing a SQL queries as well, those are T-SQL queries. Okay, so I want to close all these, and I want to open only AdventureWorks database. So inside the AdventureWorks database, what are the stored procedures we have? For example, I have this stored procedure. Okay, so rest of all I'm going to close. So instead of a stored procedure, you can execute this SQL query as well, no problem. Okay, so you just start the run. I'm sorry, I think I forgot to save this trace information. I want to stop it, and new trace, connect, and this is red bus, and this template you can take tuning template and save to a file. So where you want to save this into a file, I want to save into downloads redbus.trc. Under the event selections, under column filters, database name, like I'm sorry, that is AdventureWorks. uh, is it AdventureWorks? Right, just copy this, come over here, just rename it, paste over here. Okay, click OK. Now we can start the run. So I'm going to execute this query. Okay, this is the SQL query, and the tree started. See, this is the SQL query we are just executing. How much time it has taken? 2682 milliseconds. What is the session ID? The session ID is 6. This is the session ID. Okay, so in this way you can trace out the information, and you can execute the same thing many number of times, no problem. Or if you want to call this procedure, yes, just select that procedure and call it. Okay, and the tracing info, see dbo.ssrs, how much time it is taking. See, if you observe one thing over here, okay, this is taking 1794. The same query I have put inside a stored procedure, but this 2682, how much time it is taking? This is query I am executing individually. The reason why it is taking some less time is the stored procedure is already pre-compiled. It no need to check for the syntax, any syntax errors, and the compilation. So it saves that compilation time. That is the reason it is taking some less time. Okay, just I want to stop the tracing, then I can close it. Okay, now whatever the tracing information you have traced, so that information I want to send for analysis. What are the possible ways to improve the performance of that query? Okay, so if you want to do some analysis, we have a tool that is a database engine tuning advisory tool. So this tool, what it will do, it will you just upload that tracing file information. Okay, so I'm going to upload the trace file information over here, redbus.trc, and on what database you want to do this one, AdventureWorks. You just select that AdventureWorks. It will start the analysis. Click start. So if there is any suggestions to create the indexes to improve the performance, it will definitely give, even with the create syntaxes as well. For example, it is required to create a indexes. See here, it has given 3 suggestions for us. What suggestions it has given? Those 3 recommendations are create, 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 and what tables? Dim product, fact internet sales. On these 3 tables, you have to create what you have to create. Those are indexes. So on 2 tables, it has given scripts to create the indexes, and 1 table you have to run the statistics. See, we'll see the second one. It will generate the script. You just copy and come over here. See here, it has given create non-clustered index on this particular div product table based on these 2 columns. Okay, so this is include. What is include? So when you are going to create the clustered indexes, sometimes you can put only 16 columns here, over here. More than 16 columns you can't put. In that situation, you can include as many number of columns over here. Okay, so it has given a non-clustered index to improve the performance over here, and also here one more, that is fact internet sales. On this fact internet sales, you can create one more index, that is this is also non-clustered index on product key column. So then you can improve the performance. Okay, whatever the first one, create statistics. What statistics it is suggesting to us? Create statistics on the product certificate. Okay, so whatever the suggestions it has given, if you are you don't need to copy all these things on over here. Automatically, if you are under actions, apply recommendations, if you are clicking apply recommendations, it will execute whatever the commands over here, and it will create the indexes. So the next time it will give the best performance for you. Okay, that is the one way. And the second way, you have to see the execution plan. You know the execution plan, there are one is estimated execution plan, and the next one is actual execution plan. Estimated means it is just estimating some roadmap. This is actual. After executing your SQL query, it will give the actual execution plan. Whenever you are going to execute any SQL query, the SQL Server database engine, what it will do in the background, first it will create one plan. What is the best way to execute a SQL Server? What is the best way to execute a SQL query? It will try to find out the best way, and it will give some idea. Okay, this is my plan and this is my roadmap to execute the SQL query and to give a result back to you. So that how it is going to execute, if you want to see, you just click on the estimated execution plan. Could not find stored procedure. See, okay, so now it will give estimated execution plan. Okay, so you have to see in which area it is taking more cost operator. Wherever it has taking more cost operator, then definitely that on that particular table you have to do some focus. Here it is going to do the entire scan for the fact internet sales on this particular area. So you have to focus on this particular table and to create some indexes. There is something indexes are missing definitely. Okay, so you have to focus on this particular area. Is there any indexes are missing, and to create the indexes. Then if you have the proper indexes, so it is searching for the value over here, and it is taking too much time. The cost operator is nothing but it is calculating based on the how much CPU it is using, how much input output. Input means whatever the SQL query you are giving input, and whatever the result is giving output. So every time it is going to read the value from your SQL Server table, that is input output values. So how much processor it is going to use, the entire calculation is nothing but how much time it is going to use, that will calculate the cost operator. So try to reduce this cost operator. Okay, so if you have the proper indexes, you don't get this kind of issues. This is the there is no much difference between estimated and actual execution plan. There are very less uh, difference. So if you want to see the same thing for it is giving the roadmap like this way. From your ending, from here onwards, it is going to give. For example, this is a fact internet sales table, and this is dim product table. Okay, so here it is dim subcategory table and dim product category table, right? First we have joined dim product category and dim product subcategory table. This is dim product category table, this is dim product category, this is subcategory. So this is one table and this is this table, and here it has joined, right? So it has joined the table. Then what happened, the next join type is this fact table with product table, and it has joined the result, final result, whatever the result after joining this one, after joining these two tables is coming over here. Then finally it has given the select statement over here. Okay, so this is the estimated. If you observe the actual as well, you just click on the actual and execute the query. That plan it will give nothing difference, the same thing. Okay, there is no much difference for the clustered, sorry, estimated and actual execution plan. Okay, so one suggestion I am giving when you are writing any SQL queries, select star from emp as e inner join department as d on e dot department number equal to d dot department number. This is the one query, and the another query is select star from department as D, inner join EMP as E. So D dot department number. So which query is giving better performance? In EMP table I have one crore records, and in the department table I have 1 lakh records. 1 lakh, 1 crore. Which one is giving better performance? Any idea? Which one is the better among these two? Definitely the first one. The reason why the first one, whenever you are joining any tables, whatever the first query, first table, left table, and this is right table, which table having more number of records? More number of records. So you should use that table as a left table. In the department table, I have 1 lakh records. In the EMP table, I have 1 crore records. But you are putting that is a right side table. Don't use this kind of situation. Which table you have a more number of records? Whenever you are going to join 4 tables, first try to find out which table having more number of records. Then start select star from that table. Then what is the table having more number of records? Second priority, third priority, fourth priority. That is the one best technique. It will helpful for you, and it will save a lot of time. And the second situation is, I have one query having 50 lines of SQL query, and finally it is giving one result. I have another query, and this is also having a lot of logic, and it will give some result. Whatever the result is coming from query 1, whatever the result is coming from second query, what I want to do, I want to join these two queries. So what you can do, the people what they are doing some derived table, like, so they will give this query alias name as a, inner join, and this table, this query result b, and they are going to join directly two queries. Don't do that. You just put whatever the data is coming from this query into one temporary table, and whatever the result is coming from this query into temporary table b. Okay, you just write down a simple query temp a inner join temp b. That will give a best performance. Okay, and also if you have a big query, and what you can do, so whatever the big query result is coming, so try to use common table expression. And if you want whatever the result is coming here, that result if you want to join with another physical table, you can use common table expression. That also will give the best performance. Okay, so there are some small techniques are there, like you have to write down, instead of star you can write down all the list of the columns when you are writing SQL queries. So those are very basic. These are some high level things when you are going to do some performance tuning. Okay, there is a lot of things that is never in topic for performance tuning. Okay, thank you.